they can use it to solve. The discriminant cannot solve a quadratic. So the discriminant formula is not used for solving a quadratic. Now, when we talk about quadratic formula, you may see a part of the discriminant formula show up again. So there is connections to it. All right. So now, whenever you find the discriminant or solve any quadratic equation, you always got to make sure it is in its standard form. So ax squared plus bx plus c is equal to 0. That's true for when you're factoring. That's true from when you're using quadratic formula. That's true when you're using solving by, actually, no, you don't really need for that, but that's true for most methods of solving quadratics. What? Now, another thing to note, A, B, and C, it's very important that you identify them because they show up in the discriminant formula. So the discriminant formula is b squared minus 4ac. Now, just so you're aware, no variables in the formula. I only want numbers. So do not put any x squareds or x's in that formula. It's just numbers. Now, when you move things around the equal sign, there's also a couple of things to keep in mind. Your a value should always be positive. All right, so if your a value is not, you need to move whatever side the a value is negative on to the other side. All right, whether that be the right or the left. Another thing to note, a is always connected to x squared. B is always connected to x, and C is always the constant, so no variable. That does not change. So sometimes you may not have a B value, sometimes you may not have a C value. You should always have an A value if it's a quadratic. But just note that sometimes you don't have B or C. All right, and that's okay. You just put 0 in those places. So, now, why is finding the discriminant important? It's based off of what it tells us. So what the discriminant tells us. So if your discriminant is positive, so I'm going to say capital D for discriminant. So if your discriminant is positive, it tells us that we have two real solutions. So in other words, our solution will not contain I, and we will have two of them. If your discriminant is equal to 0, that means you have one real solution. And if your discriminant is negative, that means you have two imaginary solutions. So that means that there will be an I contained in your answer. Now, not only can whether it's positive, negative, or 0 tell us something, also whether it's a perfect square or not can tell us some stuff, but it only applies to the real solutions. So only for positive discriminant and 0. So if the number that's a discriminant is a perfect square, so 1, 4, 9, 16, etc., if it's a perfect square, that means we have rational solutions. Solution or solutions, depending. And if the number is not a perfect square, your answer should be irrational. Now, just note, when you have the discriminant equal to 0, it's always going to be rational. All right, because if you think about it, 0 is always going to be a perfect square. Because you take the square root of 0, it's always going to be 0. So if you have d equals 0, you have one real rational solution. Now, the plus minus, the positive discriminant, depending on whether that discriminant is a perfect square or not, tells us whether we have two rational solutions or two irrational solutions. So, just real quick, what's rational mean? What does rational mean? It's what? Well, it is a real number. Duh, it's part of the real number family.
It's not a fraction.
So it actually can be a fraction. Rational means it is a fraction, or it can be turned into one. Yes?
A decimal that terminates and repeats.
Right, a decimal that either terminates or repeats with a clear pattern. Now, irrational means no matter how hard we try, it will never turn into a fraction, and the decimal will go on forever and ever, but there's no clear pattern, so we can't say it repeats. All right? So again, why knowing the discriminant is important? Because if we can figure out the discriminant, we can at least get an idea of what type of solutions we should be getting at the end. So like, for example, let's say later on this week when we do quadratic formula, you're like, okay, I want to make sure that I get somewhere in ballpark of the correct answer. Take the discriminant. Let's say it was positive and a perfect square. That means you should get two real solutions, so no i's. And it should be rational, so no weird decimals or no square roots left over. All right. Let's say, you got a negative discriminant. That means you should have an imaginary solution. So that means your answer should contain an I in it. All right. That's some of the things that the discriminant can tell us about. All right. So you gotta know that stuff. And once again, I would make this note. The discriminant formula does not, emphasis on not, solve quadratic equations. So the discriminant formula does not solve quadratic equations. You cannot use it to solve a quadratic at all. All right. If you solve a quadratic, like say it was on your test next week and you solve a quadratic using the discriminant formula, I will instantly mark it wrong because it's not a solution. It's just a number that tells us about what the solutions will look like. That's it. All right, so let's test this out. So let's look at letter A. First off, is my x squared value positive? Yes. Is RES set equal to 0? Yes, so I can go straight into identifying my A, B, C. So what's my A value? 1, because I don't want the R squared. What's my B value? C? 2. So then we're going to plug that into the formula B squared minus 4AC. So my B value is 5, so 5 squared minus 4 times A, which is 1, times C, which is 2. And we're just going to do some simplifying. What's 5 squared? 25. What's negative 4 times 1? Negative 4 times 2? Negative 8. 25 minus 8 is 17. So my discriminant is 17. So based off of that answer, first off, is it positive, negative, or 0? Yes.
Wouldn't it be like 13 because like we did multiply the other one for like one?
Negative 4 times 1 is negative.
You're just doing negative 4 times the first one.
Yeah, it's 3 together. So if you put negative 4 times 1 times 2 in your calculator, you'll get negative 8. So it's 17. So what does that say about our solutions? two real solutions. And will they be irrational or rational? Irrational. 17 is definitely not a perfect square. So we have two irrational solutions. So if we were to solve that by hand, which we can't until we learn quadratic formula, we would get we'll contain a square root still in our answer. All right. So we will contain a square root still in our answer without a perfect square underneath it. Any questions on that one? So again, it's just plug and chugging into a formula, guys. It's not difficult. You can honestly put this in your calculator. You just got to make sure that you put parentheses around at the very least this part. All right, let's look at this next one. Letter C. So first off, is my x squared positive? No. So now I know which side I need to move to the other side. So that means I'm moving the left side to the right side. So I'm going to add. Stop. So I'm going to add 7n squared to the other side. And I'm also going to subtract 16n, which I'm going to subtract 16n to the 8n because they're like terms, and then add the 7n squared to the other side. So those go away. I get 0 is equal to, make sure you write it in standard form, so 7n squared minus 8n. Now, if having that 0 on the left side freaks you out, you're more than welcome to rewrite it, just switching which side the things are on the equal sign, which you're totally capable of doing as long as you keep it consistent. These two equations are equivalent. All right, so if you have to have that 0 on the right side, you can just flip-flop. So, ABC. What's A? What's A? 7. What's B? Negative 8. Make sure you keep the sign with it. And what's C? 0. So there's no constant value on the left side of the equal sign, so we have to assume it's 0. So if you don't have an A or you don't have a B, assume it's 0. Not an A. If you don't have a C, if you don't have a B, assume it's 0. Now, let's put in the formula b squared minus 4ac. So I have negative 8 squared. Make sure, especially if you put that in your calculator, the negative 8's in parentheses. Remember, if you just put minus 8 squared with no parentheses around it, your calculator reads that as 8 squared times negative 1. If you want a true negative 8 squared, make sure the negative 8 is in parentheses. Minus 4 times a, which is 7, times c, which is 0. So what's negative 8 squared? 64. Now, negative 4 times 7 is negative 28. But what's anything times 0? 0. So we're going to subtract 0. So my answer is what? 64. So my discriminant is 64. So what does that say about my solutions? Two real rational solutions. Why'd you say rational, Colden? So why did you say that it was rational? You're correct, but why is it? Because the discriminant's a perfect square. 64 is a perfect square. If you take the square root of 64, you will get a nice, pretty number. So that means that 1, that's factorable. So if that's another thing that discriminant helps you with. With factorable equations, at least with quadratic factors. Guys, put the phones up. At least with quadratic factors. You got to... So when it comes to factoring quadratics, because like the ones I've been doing for warm-up have not necessarily been quadratics. Like the one we did today, not a quadratic, so it doesn't apply. But true blue quadratics mean you start with the highest exponent being x squared. You're always going to have rational answers if you are solving by factoring with quadratics. All right, but that's only if it's a true blue quadratic where the highest exponent is 2 at the beginning. So that's also a way you can tell if your function is factorable, and even if attempting solving by factoring is worth the hassle. All right, because sometimes it's like, you want to try to factor it first because solving by factoring is a lot easier than the other ways. But you can't always solve by factoring, especially if you have a polynomial that's unfactorable. All right. So this one, you can solve by factoring if we wanted to, because we will end up getting rational solutions. So that's another way that you can figure out if factoring is even worth your time. Just take the discriminant real quick. If that discriminant's a perfect square, then yes, you can factor it. Does that make sense? All right, let's do one more together, and then I'll have you guys try one out on your own. All right, letter B. What's my first step? What am I moving, though? The left side, because my x squared is negative. So I'm going to add both of these to the left. So I'm going to add 6x squared and add, oops, not there, and add 6. That goes away. Get 0 is equal to 6x squared minus 7x minus 3. Now, just for my peace of mind, I'm going to flip-flop the equal, what's around the equal sign. Just for consistency's sake. All right, A, B, C, what are they? 6 is A, negative 7 is B, negative 3 is C. Then I want to put in the formula B squared minus 4AC. So I have negative 7 squared minus 4 times 6, which is my A, times negative 3, which is my C. So what is negative 7 squared? 49. All right, what's negative 4 times, or let's do it this way. What's negative 4 times negative 3? Positive 12 times 6. 72. So if I add those together, I get 121. So what does that say about my solutions if I were to solve that quadratic? 2 real rational solutions. Negative 4 times 6 is negative 24 times negative 3. That's positive 72. You could also do it because multiplication is commutative. Negative 4 times negative 3, which is positive 12 times 6, 72. So it's just like simple number sense, really. So we have 2 real rational solutions. So if I tried to factor this, would I be successful? Yeah, I would. All right. So factoring is worth my time. All right, try this last one on your own. Get an answer, share with your group mate.
Is 0 irrational?
0 is a perfect square, so it'd be rational. All right. Check your answer. So I got 0. I got 0 as my discriminant. Since 0 is a perfect square, that means my answer is going to be rational. And since it is 0, that means it's one real solution. So it's one real rational solution. So, guys, when is it the case that you only have one solution? Well, duh, but I'm talking about but what I'm talking about is if you were looking at a graph, what would be the only case in which you would only have one solution? The vertex is not necessarily the origin, but you're close. Say it again. Not the y-intercept, but you're close. The x-intercept. When the vertex is your x-intercept, that is the only time you'll end up with only one solution, when your vertex is the x-intercept. All right. So if you were looking at a graph, your vertex of that graph would be the x-intercept. And remember, vertex is the only point on a quadratic where it has no symmetry. So there should not be two solutions if the vertex is on the x-axis. All right, now that's discriminant. Now, like I said, that's mainly just helpful information for what our answers should look like when we get, oh my gosh, what my answers should look like when we get into solving. All right. Now, another thing we got to review before we get into solving, which we're not going to get into solving until tomorrow, but this is stuff that we talked about at the beginning of the unit. So 4.1 and 4.2. We got to be able to simplify radicals. So we've been doing that a lot in this class. Remember, no radicands, or the number under the radical, can have perfect square factors other than 1 in them. No radicand can contain a fraction, and no radicals appear in the denominator of the fraction. So we got to simplify the radicals, and we also have to rationalize the denominators. All right, so let's do some review here. So look at the next page. How would I break down 180, square root of 180? So what am I looking for? So how do I simplify the square root of 180? What's my first step? Why? Right. Find two factors of 180 where one's a perfect square. Now, what happens if you have multiple perfect squares that work? You pick the highest one. Good. So take a minute. Find the perfect square that's the highest perfect square that can be divided into 180. So remember, if your factors are not perfect squares, we do not care about them because there's plenty of factors that can go into 180, but there's only like 2 that are perfect squares. Yeah, go ahead. There's a new Delta math, and the rest of the notes and video will be posted in Canvas.
No, there's. Yeah. 180 by 36.
All right, you guys find it? Uh, at this point, we're just reviewing stuff from 4.1, so you're good. So, so have you guys found? Have you guys found the largest perfect square factor? It's 36, and it goes with 5. So remember, we could rewrite this as the square root of 36 times 5, which we can then break apart into two individual radicals. So the square root of 36 times the square root of 5. What's my next step? You simplify the 36, so square root of 36 is 6, and it's still times the square root of 5. So your answer is 6 square root 5. All right. The next one. Take a guess. What do you think the largest perfect square factor is going to be? Definitely 25. 25 times what is 125? 5. So I could rewrite this as how? Well, not yet. I'm going to do square root of 25 times the square root of 5. Then it's 5 square root 5. For right now, I still want you guys to list all the steps. Now, think carefully about this one. What do you think is the largest perfect square?
408.
Not 408.
800. It's just 400.
Oh, 400. Yeah. So, at least on the list that I gave you, the highest perfect square that'd be able to go in is 400 and then 8. All right. I thought you said 408, like the number, but that's where my brain is today. So, if I break this down, I have the square root of 400 times the square root of 8. So, what's the square root of 400? 20 times the square root of 8. Now, what's the issue here? You can still take stuff out of 8. So, guys, the actual largest perfect square factor was 1600. All right. Now, the only reason I know that is because that's what 40 squared is. But that wasn't on the list, and that's okay. All right. Take the biggest that you at least know on the list, and then if you still have to break down again, that's okay. So for 8, what's the biggest perfect square? 4 and 2. So you still got the 20. That's still applied here. But then we take the square root of 4 and times it to the square root of 2. So what's the square root of 4? 2. So I have 20 times 2 times the square root of 2. And then I just got to simplify 20 times 2, which is 40. So like I said, the highest perfect square is actually 1600. That could go into 3200. That would be 1602. Square root of 1600 is 40. So that makes sense. But again, I didn't expect you to know that highest perfect square off the top of your head, because all you guys know, at least for the most part, is up to 20 squared. All right. But that is an example of what you do and what you should be looking for every time you simplify a radical. Make sure the radicand, or the number under the radical, has no more perfect square factors. If it does, it's okay. You don't need to start over. You just need to simplify that radical and then multiply whatever number you take out to the number that's already outside. Does that make sense? All right. Now, that's simplifying. Let's look at fractional radicals. So, just like multiplication, because remember, fractions is just another way to show what operation? Division. Just like how multiplication, we can split apart something times something under a single radical into two separate radicals being multiplied together. Division is the same way. So if we have 4 over 25 under the radical, we can separate it to be square root of 4 over the square root of 25. And then we can simplify. What's the square root of 4? Square root of 25? 5. Your answer is 2/5. Now, the next one you can do in two different ways. All right? The first way is like I just told you, separate it into two fractions. All right. And then simplify them. So what's the highest perfect square that'll go in the 98? Nope. 49. 49 and 2. So this would be what simplified? 7 square root 2. What about the square root of 8? 4 and 2. So what would it be simplified? 2 square root 2. Now, if I look at this, what happens? This, well, not just that. So we actually don't have to worry about rationalizing in this case because something else happens. They have the square root in the top and the bottom. So what happens to them? They cancel out. Square root of 2 divided by the square root of 2 is just 1. So we can cancel them out. So my answer is 7/2. The other way you could have approached it is to actually simplify what's under the radical first and then separate. All right, because 98 over 8, can that be simplified? Like the fraction? Yeah. What is that fraction simplified down to? So 98 over 8, what can I it can, if you divide both the top and the bottom by 2, it can go down to 49 over 4 square roots, which we can then separate into 2 square roots. Square root of 49 is 7. Square root of 4 is 2. We still get 7/2. Boys, you guys have a new Delta math, and we're almost done with the notes. You just got to get the last little tidbit.
What is the joule?
Tuesday. So, doesn't matter which method you do. You can either do this one or this one. So this is method 1, method 2. Doesn't matter as long as you can clearly get an answer. All right? So, last one. This one, 1/5, we can't simplify any further, so we have to go straight into the separation. So square root of 1 over square root of 5. What's the square root of 1? 1. Now, here's the problem. Square root of 5, we can't simplify any further. Not a perfect square, and we can't simplify the radical because 5 is prime. So, but we know that we don't like square roots in the denominator. So what do we have to do to get rid of that square root in the denominator? Multiply what? Not just the square root of 5. Square root of 5 over the square root of 5. And what's that called? What's this process called? Nope. What's this process called when we're trying to get rid of the square root in the denominator? Starts with an R. Rationalizing the denominator. Good. So if I multiply straight across, do not cross multiply. Get cross multiplying out of your little brain. You don't do it hardly ever anymore in advanced mathematics unless you're solving by proportions. This is not one of those things. So what's 1 times the square root of 5? 1 square root of 5 or just the square root of 5. Now, what's the square root of 5 times the square root of 5? Nope. You could write it as the square root of 25. Simplify a little more. Square root of 5 over what? 5. Now remember, you could also have read square root of 5 times the square root of 5 as the square root of 5 squared. Which what would happen? The radical and the square would cancel out, so we can just go straight to 5. So you could do the square root of 25 step, that's fine. But you could also just go straight to 5 if you wanted to, because you just have to identify that square root of 5 times the square root of 5 is squaring that number, which would cancel out the radical. Either way works, whatever you're most comfortable with. So that being said, let's do some more rationalizing the denominators. So this one, what do I do? How? Right, square root of 3 over the square root of 3. So what's 1 times the square root of 3? Square root of 3. What's the square root of 3 times the square root of 3? It's just 3. You could also say the square root of 9, but square root of 9 is just 3 anyway. So that's our answer. Because we can't touch the 3 that's under the radical sign, so we can't simplify that 3 with the 3 in the denominator. Because again, the radical sign is kind of keeping us from touching that 3 under the radical. What about this one? What do I do first? Multiply by the square root of 2 over the square root of 2. What's 4 times the square root of 2? 4 square root of 2. Do not multiply a number that's not under a radical by the number that's under a radical. It is not the square root of 8. All right? You can only do inside the radical times inside the radical, outside the radical times outside the radical. You can't mix. So if you have an outside times an inside, you just smush them together into one expression. What's the square root of 2 times the square root of 2? 2. Now, am I done simplifying? No. Why? 4 over 2, that fraction can be simplified to what? 2 square root 2. 4 divided by 2 is 2. So that's my answer. All right, last one. Walk me through it. Times plus square root of 3 over the square root of 3, which gives me what? 2 square root 3 over 3. Can I simplify any further? Nope. 2/3 is simplified completely, so we're done. So again, why are we reviewing this? You will see it again when we're solving by completing the square, which is tomorrow, and by quadratic formula, which is Friday. All right. So today's lesson was pretty easy because discriminants is just easy to find. And the radical stuff we have already learned before. All right. Okay, so your classwork for today, and you got a solid 40 minutes, is another Delta Math. All right, it's just covering discriminant, and I also threw on some review for simplifying radicals and rationalizing denominators. All right. So go ahead and get to work. Make sure you're using this time wisely. You have 40 minutes. You could